Dear students, today we will talk about big data analysis techniques. So in this chapter, what are the most important things? We will see that the normal data mining techniques, how can we implement in the perspective of the big data? Because in the big data, we have a high volume, high velocity, and high velocity. So in this context, how the data mining techniques can be usefully implemented. So the symbol which is used for the data analysis is the one which you can see in front of you, and that is the symbol for data analysis. So usually when we do the quantitative analysis, so the expected output is considered to be a numerical result. So it means that whenever you are doing any quantitative analysis with any formulas, the answer would be in a numerical form. Now, if you have a qualitative results, like for example, if you have like some interviews, some like surveys, which is mostly like qualitative, so which are descriptive in nature, so and cannot be generalized into the entire data set. So for that one, we need some descriptive results, and so it means that there are two kind of things. The first one is for quantitative analysis, you get the numerical value. For qualitative, which is like more interview based, more textual based, like more AI chat box, so in that case you will get like a descriptive result, and the human can interpret the data. Now the typical symbol which is we use for the data mining is this with the X and the numbers you can see in front of you. So, being to do some experiment with the two different emails or with the two different data or big data, we see that we shoot two animals, two emails, and then these emails, what we do, we check that which email brings more customer for us, right? So, so two different emails version are sent out simultaneously, means at a time there's a marketing campaign and to see which version brings more prospective customer, right? So usually in data mining we do these kind of experiments in marketing analytics and then see the results, and especially when you have a huge amount of emails, and and the emails are being spread to the different customers around the country. Now we see that, as you already might know, in the normal statistics, we that one variable is on the x-axis, another variable on the y-axis, and it shows that linear behavior. It means if one variable is increasing, the another variable is increasing. So this is a very typical example for linear regression. Now we see when one variable increasing, the other may stay the same, increase or decrease arbitrarily, right? So this is just like an example. This could be three different options. Now in this case, it's opposite. So in this case, one variable is increasing and another is decreasing. So you can see that on x-axis, the behavior of one variable is different, and y-axis, the behavior is different. And that's the reason that the line is on a different side with respect to the previous figure. So if you compare with this figure, this is like opposite. Now, if you see, yeah, linear regression, if you see over here with the shift of y, if the y is not starting from the zero, the y is starting maybe from the 2 or 3 point, and in that case, if you see, still the both variables are going in the same direction. X is increasing, which is independent variable, and y is increasing, which is independent variable. Now, in this case, this is a non-linear regression. In this case, it's the power of x is not x and y is not one, but it's like it could be square or it could be cube. So in this case, you might get a parabolic shape or hyperbolic shape, and you can see this kind of shape is a non-linear regression, and you can observe this shape in a clustering as well. So usually machine learning, it helps us to automatically classify your data set. So if you train your model with respect to the good or bad, okay, or yes or no, or benign or malignant, or any kind of classification you do it, and you train your data set, so machines are now able to classify your testing data. So once you train on the training data, and then you can do on the testing data. And the third thing, you can also validate it with a different kind of data. Now, yes, I talk when I talk about like clustering. So here is an example for clustering. So a scatter graph is usually used to cluster your data. So here you can see three kind of clusterings, three kind of customers. One customer in the blue shape, another in the green, one another in a red shape, right? So these are the different areas, different customers for different products. You can see. Now there could be some customers which are not like included in these three one. They are like maybe they are some foreigners or just visitors, so they could not be considered as a proper customer, and that could be an outlier. Or the outlier could be a fraudulent case which doesn't pay back the money to the bank, or it could be like some virus which is not having a similar behavior like the normal communication. Now, as we talk about the big data, so big data is very like complex with respect to the structure, with respect to the semantics, understanding of the data. So usually in big data we have documents, and documents can easily be processed by MongoDB software. That is very popular software. You can like extract the data from that one using the MongoDB campus or Mongo shell, right? So the entities are extracted from the text file using semantic rules. Semantic rules means the rules you make it just for understanding and extracting the data. And the structure is normally with respect to the structure SQL, so they can be searched as well. So from the documents you extract the data with respect to the names, URL, city, country, phone number, and these documents can be stored in a normal SQL, or it could be stored in the JSON, it could be stored in XML format, it could be stored in the BSON as well, right? So binary JSON format. Now, the another thing is most important thing that is a heat chart, here the heat map chart, and it depicts about the sales of three divisions like division A, B, and C, and they are categorized with the different colors, and the data is from January to the June for the 6 month. So the red color is means the target is below, above, and the green is above the target, and the third color is about on the orange color is on the target, right? So this is the visual representation, then how we can represent the company sales in a heat map with respect to the big data. Now, this is another example, like if you have a huge data and you can represent with the heat map of the US sales figures from 2013, and those sales which are less than 100 million. So it is depicted with the red color, and the one which is like higher than 5 million, it is depicted with the yellowish color. Now we have the time series data. So in the time series data, line chart depicts the sales time series from 1990 to 1996. You can see over here, and it can be like visualized, and from like the sale is from 2 million, and it is reaching to approximately 5 million, right? Some are touching in 1996 is touching to the 5 millions, right? And the trends we see, there are two trends. The blackish trend is for the original like data, and the one which is the prediction is the bluish trend. So this is like that how can we depict the data in a time series with respect to the big data. So you can see, so we have 6 year data, which is almost like you can consider as a high volume. When the volume is high, so we consider it as a big data. Now, the last thing is about like social network. As we know that social network also is leading us to the big data. If you see the Facebook, Instagram, like even the YouTube, you can see the TikTok. So a lot of connections are there, human to human connections, video to video connection, recommendation to recommendations connections, and you can see that. And the different likes and all these things. So all this like uploads of the images, text data, comments, it like gives birth to the big data, right? So the social network is contributing towards to the big data, and because the speed is also high, like in 1 hour you can see, or even in 1 minute you can see how many videos are uploaded on YouTube in a specific country. Or if you look at the world level, so it's huge. So they need big clusters computers to store all this high flux of the data into the YouTube server or Instagram server or in any other, like social network servers, right? So thank you very much and see you in the next class.